Now rotations. You're expected to be able to rotate a shape about a given point, either clockwise or anti-clockwise, and through 90, 180 or 270 degrees. Of course, 90 degrees is a quarter turn, 180 is a half turn, 270 is a three-quarter turn. So you could really do with a piece of tracing paper for this. Either baking paper or tissue paper makes a good substitute. Right, so we've got shape A, and we are going to rotate this shape clockwise through 90 degrees about the origin. So first, mark your center of rotation at the origin at 0, 0, and join it to the shape, like this. Now put the tracing paper on top of the shape and the center of rotation and trace the picture. And also draw an arrow pointing straight up from the center of rotation, because that makes it easier to see what angle you've turned through. So there's the tracing paper with the image traced onto it. And there's your arrow pointing straight up from the center of rotation. Now put your pencil point on the center of rotation. Turn the tracing paper clockwise through 90 degrees, so a quarter turn. So you'll know when you've done that because this arrow will become horizontal. And then transfer the shape to its new position on the grid. So we put the pencil point here, rotate, end up with it here, and that's where your shape has to end up. So you need to transfer it to that location. So this vertex is going to be at 6, -3. This one is going to be at 2, -6. And this one at 2, -3. It can be helpful once you've initially traced the shape to also trace it onto the back of the tracing paper and then go over it by pressing on your pencil so that it prints onto the grid. But you don't have to do it that way, it's only a suggestion. So there's what we end up with, and let's get rid of the tracing paper. Okay, now I would like you to try rotating the same shape anti-clockwise through 180 degrees about the origin. So pause the video, have a go, and press play when you're ready to see the answer. And the answer, we've gone anti-clockwise, so in this direction, and you end up here. In fact, if you're going through 180 degrees, it doesn't matter whether you go clockwise or anti-clockwise because they're both half a turn, so they both have you ending up in the same place. Now, I'd like you to rotate shape D anti-clockwise through 90 degrees about the point 6, -2. Pause the video, have a go, and press play when you're ready to see the solution. So the center of rotation at 6, -2, join it to the shape. Don't forget your vertical arrow, or horizontal if you prefer, it really doesn't matter. Rotate through 90 degrees until this vertical arrow is horizontal. And when you've done that, you'll end up with your shape here. So this point is on the y-axis at -6. This point is at -1, -3. And this one is at 4, -5. Can you think of another way to describe this transformation? It's still a rotation, but you could describe it as a rotation clockwise through 270 degrees about the point 6, -2. So it's still the same center of rotation, but if you go quarter of a turn one way, it has the same effect as if you go 3/4 of a turn the other way. What transformation would return it to its original position? So from D dashed back to D. Well, again, it's a rotation, the same center, but this time it will be clockwise through 90 degrees or anti-clockwise through 270 degrees. So same angle as before, but opposite direction. Now, sometimes the center of rotation can be inside the shape. So I'd like you now to try rotating this shape here clockwise through 90 degrees about the point -3, 2. Pause the video, work out your answer, press play when you're ready to see it. Your center of rotation then is here. Join that to any vertex. I've used this one, but it doesn't really matter. Don't forget your vertical arrow on the tracing paper. Rotate your tracing paper 1/4 of a turn clockwise, so your arrow ends up pointing this way, and this joining line is pointing this way, and your shape ends up there. Now you do get questions where you need to identify the transformation and describe it. In the case of a rotation, that means you need to work out where the center of rotation is. And that can be quite difficult. I'm only really including it here for completeness, but it really is the top end of foundation, this. So you've got two approaches you can use. The first one is the tracing paper method, which should get you there, but it's a bit hit and miss. So you put your tracing paper over the shape and wherever you think the center of rotation is likely to be, and you trace the shape. So there's your tracing paper with the shape traced onto it. Now you need to have a guess at where you think the center of rotation is going to be. Put your pencil point on it and rotate the paper. Now, if you've got no idea, then the origin 0, 0 is a good place to start, because that's quite often the answer. So put your pencil point on here, rotate your tracing paper, and in this case, we haven't got a match. If the shape ends up right on top of the image, then you've got the right center of rotation. If it doesn't, you need to try somewhere else. Now, in this case, clearly it isn't a match. In fact, it's facing the wrong way. So the center of rotation must be somewhere over this side of the original shape. So just keep trying until you find a point that gives you a match. The other method uses our old friend perpendicular bisectors. So you need to draw a line joining one vertex on the original shape to its corresponding vertex on the image. So on D, if we start with this top vertex here, that is between, if it's a right-angled triangle, it's between the shortest side and the hypotenuse. There's the hypotenuse, there's the shortest side, so this is the corresponding vertex on the image. So we draw a line from here to here, and then we draw the perpendicular bisector of that line. Now you can use the compasses approach, the same as you've already learned, or you can think, well, this is going 6 across and 8 up. So halfway along is going to be 3 across and 4 up, so it's going to go through this point here. And if it's at right angles, it must be going 4 across and 3 down, like that. So either method is okay, as long as you end up with a line that crosses this one halfway along and has a right angle where it joins. Now do the same thing for a different pair of corresponding vertices. So let's use this one here. This is between the hypotenuse and the other shorter side. So that corresponds to this one on the image. So there's our joining line. And we do our perpendicular bisector again, like this. And the point where the perpendicular bisectors cross is your center of rotation. So in this case, it's here. at 6, -2, which of course is what it was when we did it on the previous slide. So that is it for rotations. We've just got enlargements left to do now on this topic.